Okay, in this video we're going to continue talking about arithmetic sequences. So by the end of this video you'll be able to find the sums of sequences using what's called summation notation. Just a quick review, we talked about arithmetic sequences and we looked at two different forms, the recursive form and the explicit form. Remember, this is what the recursive form looks like. The only issue with that is that in order to find the fifth term, you have to know the fourth term, and in order to find the 160th term, you have to know the 159th term. So that gets to be a little bit cumbersome. The explicit form allows you to find any term as long as you know the first term and the common difference. So just a quick review on those two different types of forms. Now, if we had a sequence and we wanted to add up all the terms, say we had a sequence that went like this. We wanted to add up the first four terms. Well, there's a notation for that, and that's called summation notation, and it looks like this. It uses the Greek letter sigma. The notation works by writing the first term on the bottom all the way to the mth term. So if I want to find the first m terms, I'm going to add the first term, the second term, the third term, all the way up to the mth term. So here's what it looks like. In example 7 it says complete each or compute each sum. And in part A it's asking us to find the first through fifth term of this sequence. So all I have to do is figure out the first, second, third, fourth, and fifth term. And then add them all together. So the first term, I find that by replacing the letter n with 1. 3 times 1 is 3, plus negative 7 is negative 4. The second term, I do the same. 2 times 3 is 6. 6 plus negative 7 is negative 1. 3 times 3 is 9. That's 2. 4 times 3 is 12. That's 5. And 5 times 3 is 15. That's 8. Now, if you look closely, you can see the pattern in this sequence, and that is that you're adding 3 each time. But we're trying to figure out the sum of the first 5 terms, so I just add all these numbers up. And that gives me the sum. 8 and 5 is 13, 14, 15. Minus 1, minus 4 is 10. In the same way, I can find the sum for part B. I'm looking for the first 4 terms. I put the letter n, or the number 1, in place of n. 1 minus 1 is 0, times 4 is 0, so the first term is negative 3. The second term, 2 minus 1 is 1, times 4, plus 3 is 1. And I keep going in that same way. Now you can notice negative 3 plus 4 is 1, 1 plus 4 is 5, so the next one's going to be 9. Then I add all these terms up. And I get 12. 9 plus 5 is 14, 15, 15 minus 3 is 12. Now, that works, and it's okay, except if I were asking you to find the sum of the first 100 terms, this method doesn't work as well. It takes way too long. So to demonstrate how the formula for finding the sum of the sequence came about, I'm just going to show you an example. Say I have the first 100 numbers, 1 through 100, and I want to add them all up. I could start adding by going 1 plus 2 is 3, 3 plus 3 is 6, 6. But there's a pattern if you look closely, and the pattern is this. If I take the first term and the last term, and I add them together, I get 101. And then if I take the second term and the second to last term, and I add them together, 99 plus 2 is 101. And if I keep doing that, third term, third to last term, 98 plus 3 is 101. Each pair that I add together adds up to 101. So if I've got the numbers from 1 to 100, and I pair them all up, how many pairs are there that add up to 101? Well, there's 100 numbers. If I pair them up by putting them in twos, that makes 50 pairs. So the sum of all the numbers from 1 to 100 is just whatever you get by pairing them up times however many pairs there are. That's 50. Well, using this information, you can see how the formula came about for finding the sum of a sequence, or the partial sum of a sequence, because the sequence goes on forever, so you're finding part of that sum. And that formula looks like this. To find the partial sum of an arithmetic sequence from the first term to the kth term, you just take the number of terms and divide it by 2, just like we did. We had 100 terms and we divided it by 2 to get 50. And then you multiply that by the first term added to the last term. That's what we did over here. We took the first term and the last term, and we added it together, we got 101. So this formula helps you find the sum, or the partial sum, of arithmetic sequences. So partial just meaning a sequence goes on forever, you're just looking for the first some number of terms. So let's take a look at how you can use that formula for finding the partial sum of a sequence. This example says find the 12th partial sum of the arithmetic sequence below. Now, if you look at the sequence below, you'll notice that the first term is given to you. That's easy. It's -8. It's the first term. You also should be able to look at it and figure out what the common difference is. Remember, the common difference is what you have to add to get the next term. And to find a common difference, you can take any term and subtract the previous term. So these look like the easy ones. If I take 7 and I subtract the previous term, 7 minus 2, I get 5. So the difference is 5. Now, the 12th term, if I wanted to, I could just write out and keep adding 5 and get to the 12th term, just by adding over and over again 5, 5, 5, 5, and so on. But you also know a formula, an explicit formula for finding the nth term. And that explicit formula is the first term plus n minus 1 times d. So if I want to find the 12th term, I can find the 12th term by taking the first term, which is -8, and adding 12 minus 1 times d, which is 5. 12 minus 1 is 11. 11 times 5 is 55, and 55 plus -8 is 47. That's the 12th term. That's the first term, and that's the common difference. So to find the 12th partial sum, you're going to set up the summation notation and go from n equals 1 to 12. Now, the formula says you're going to take k, which is the last term, divided by 2, multiply that by the first and the last term. So I'm going to take k, which is 12, and divide it by 2, and multiply that by the first term added to the last term. 12 divided by 2 is 6. -8 plus 47 is 39. And 39 times 6 is 234. So the kth, or the 12th partial sum of this sequence, is 234. If I add up the first 12 numbers in this sequence, I'll get a total of 234. That's it. Now, there's a lot of steps to remember, but most of it's just figuring out what the first and the last term is and then plugging that into the formula. All right, let's look at one more example. Find the sum of all the multiples from 3 to 333. Find all the multiples of 3 from 3 to 333. So first thing is, what does that mean? Well, multiples of 3 means 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So the first multiple is 3. That's this one. Second multiple is 6. Third multiple is 9. What number of multiples will get me to 333? Well, 333 divided by 3 equals 111. So this sequence is going to go from 1 all the way to 111. So to find the sum of all the multiples of 3 from 3 to 333, it's really the first term all the way to the 111th term, and that looks like this. I'm figuring out the first term to the 111th term. Okay, and to figure that out, I'm going to take the total number of terms, 111, divide it by 2, and then multiply that by the first term, which is 3, added to the last term, which is 333. 3 plus 333 is 336. Multiplied by 111 divided by 2. You can use a calculator or you can reduce, but your answer comes out to be 18,648. So once again, we're using the summation notation and the formula to find the sum of, or the partial sum of a sequence. And that's it.